Number 3 gives us an equation. It's PCl3 plus Cl2 yields PCl5. And it says that all of these are gases. And it gives us concentrations for each one of these. And then it asks a series of questions. It asks, first it wants us to calculate the reaction quotient. Then it wants to know if the system is at equilibrium, if KEQ equals 25, and which way it would shift in order to reach equilibrium. So first we will write an equilibrium expression. And so since it's not at equilibrium, we're not sure, is it at equilibrium, is it not at equilibrium? It would be improper for us to say KEQ. So we'll set it up to, like it said in the question, Q, the reaction quotient. So Q, and you calculate Q the same way you would KEQ. It is equal to the concentration of the products divided by the concentration of the reactants raised to their coefficients. The only difference is that KEQ is used exclusively when you know that you're at equilibrium, whereas Q can be used any old time. So Q would equal the concentration of PCl5 over the concentration of PCl3 multiplied by the concentration of chlorine, Cl2. And in the problem, they gave us some values for those. And it said the concentration of PCl5 is 1.1 times 10 to the minus 7. Divided by concentration of PCl3 was 9.4 times 10 to the minus 3 times the concentration of Cl2, 6.2 times 10 to the minus 2. So, get out a calculator, plug that in. Be mindful of the fact that calculators will mess up powers of 10 calculations. They don't know your orders of operation. So if I put it in my calculator, I would put it in as 1.1 E negative 7 divided by, and then I'd open up a parenthesis, 9.4 E negative 3 times 6.2 E negative 2 close parenthesis equals. So that way your calculator knows which order to do that in. These two are multiplied. So otherwise your calculator, I'm pretty sure, would divide these then multiply, but just be careful with that. And when you punch that in a calculator, you're going to get Q equals 1.9 times 10 to the minus 4. And if you don't get that, punch it in a couple more times, work until you can work the calculator correctly. No unit on Q because KEQs, Qs, they don't have unit labels. It's a concentration divided by a concentration, so those units just end up canceling out. Now Q compared to KEQ, Q is a whole lot smaller than KEQ. So the series of questions it asked us, first it wanted us to find Q, we did that. Then it wants to know, is the system at equilibrium? So in order to be at equilibrium, Q would have to equal KEQ, which it doesn't. Q is a whole lot smaller, so it is not at equilibrium. And then it wants to know which way should it shift in order to reach equilibrium. Let us consider this. So Q is calculated, it's the products over the reactants. And so if this ratio, this fraction, is too small, that means that your products are too low and that your reactants are too high, right? That's the way math works. 1/10 is smaller than 1/5. So in order for this Q value to rise up to 25, you are going to have to turn some of these reactants, a lot more of these reactants, into more of the products. And so we need more reactants to undergo a chemical change into more of the products. And so, chemistry parlance, we would say that the equilibrium needs to shift to the products, or we could also say shift to the right, because the products are on the right of the reaction. So that's how you would do that. That's how you examine Q in order to, that's how you calculate Q and compare it to KEQ in order to determine how the system will change in order to reach equilibrium. So.